And so this is going to involve a chain rule. The outside function is tangent and the inside function is the xy. So derivative of tangent will give us secant squared. And then when we chain on the derivative of the inside part, that's going to involve a product rule. So that will be the first thing times derivative of the second. Derivative of y will be dy dx plus the second thing, which would be y, times derivative of the first, and derivative of x would just be 1. So you can write that or not if you don't want to. And then derivative of x would just be 1. And so we have to get the dy dx by itself, just move everything else over. If I divide by secant squared, that would give me 1 over secant squared. And the reciprocal of secant is cosine. So this is going to be cosine squared of xy. And then I'm going to subtract over the y. And then I'm going to divide everything by x. All right, so here was the next one. Derivative of 3x squared will give us 6x. This again is going to be a product rule. The first thing will be the 2x and the second thing will be the y. So that will be first times derivative of the second plus the second thing would be y, and then derivative of the first would just be 2. So 2y. Wait, did I miss something there? No, I have my dy dx. Okay, sorry, brain went fuzzy for a second. All right, plus, and then this derivative will be 2y dy dx, and then derivative of 1 will be 0. So now we need to get dy dx by itself. I'm going to leave these two terms here and subtract both of these to the other side. So I'm going to subtract over the 6x and subtract over the 2y. And then I'm going to factor dy dx out. And then we're going to divide this over to the other side. Now I'm betting that they simplified down the answer choices a bit. We can divide all of these by 2. So that would give me negative 3x minus y over x plus y. And then I have to look back at the choices to see if they simplified it down any further than that. Let me see what they did here.
They did. They took the negative out of the numerator.
Is that the last thing they did? I wasn't sure how far they went. Yeah, okay. So if we take, oh gosh, and I'm writing on this board here, which usually I just bend the paper when I get down to the bottom, but here we go. All right, so we'll take a negative out, and that will leave you with 3x plus y over x plus y. And I think they may have written this the other way around, but your answer choice for that one was B. All right, so this one, they want us to find the derivative when x equals 1. We're going to have to figure out what y is as well. So before I do the derivative, let me just go ahead and plug in negative 1 for x. That is going to give me y equals negative 1y plus 1 plus 1. So if I add this y over, I'll have 2y equals 2, and so y is 1. So that is my work to figure out what x and y are. Now I'm going to go back and do the derivative. So looking at this original line here, that's going to be dy dx equals, and then here's another product rule. So first, derivative of the second plus second, and then derivative of x is just 1. Plus, this will be 2x, and then 1 is a constant, so that's gone. So I'm going to go ahead and plug in -1 for x and +1 for y. So this will give me a -1 dy dx plus 1, and then -2. So if I add this dy dx over, I will have 2 dy dx equals -1, and then if I divide by 2, that'll give me -1/2. All right, so this one asks for dy dx in terms of x. So I think it'll be easier if we go ahead and just get y by itself for this. To cancel out the e, we're going to do ln of both sides. And so we'll get ln sine of x equals y. And so when I do this derivative, I'll get dy dx equals, and then derivative of ln is 1 over whatever you've got. And then you have to chain on the derivative of what's inside of there. So derivative of sine would be cosine, and I'm just going to go ahead and put that in the numerator. And then cosine over sine will be cotangent. All right, so this one is asking for the second derivative at the point 4,3. So first derivative would be 2x plus 2y dy dx equals 0. And then getting dy dx by itself, I'm going to subtract over the 2x and then divide by 2y. So the 2's will cancel, and I'll have -x over y. So at this point, so my derivative at the point 4,3 will be -4/3. And I'm going to need that later, so I just went ahead and plugged that point in. But the question did ask for the second derivative. So now we're going to go and find the second derivative. So derivative of this is going to be a quotient rule. So it'll be denominator, derivative of the numerator, should just be -1, minus the numerator, and then derivative of the denominator would be dy dx over the denominator squared. And so if we want to evaluate this at the point 4,3, we're going to plug in 4 for x and 3 for y. So this first part will be -3. These negatives will cancel. X is 4, and we found that dy dx at that point was -4/3. So I'm going to put in -4/3 for that. And then over 3 squared would be 9. Now, if it's free response, you can just stop and leave it like that. But because it was multiple choice, we have to keep going until we figure out which answer choice we want to pick. So this would be -3 minus 16/3 over 9. And there are multiple ways you can get through this. What I would probably do is just multiply the numerator and the denominator by 3 to cancel out that fraction. You could also get a common denominator here. This is like totally up to you how you want to get through this. I'm just going to multiply the numerator and denominator by 3. So then my numerator would be -9. And sorry, I'm going to come over here because I ran out of space. The board's running into the wall of my desk here. So that'd be -9 minus 16. The 3's will cancel. Over 9 times 3 will be 27. And so that'll be -25 over 27. All right, so last one. So this one's also asking for f prime of x. So just going to get f of x by itself first. Same as that other question. We're just going to do ln of both sides to cancel that out. So we'll have f of x equals ln 1 plus x squared. And so derivative of ln is going to be 1 over whatever you've got, and then chain on the derivative of that stuff, which in this case would be 2x, and I'm just going to go ahead and put that in the numerator.